Okay, let's create a programming language. So the programming language is called Yerba and it's going to be written in Rust. It's not that I'm like a Rust expert, so part of my goal here is to actually gain more experience with Rust. And let's just try it out. And yes, perfect. We already can write hello world with this programming language. The only downside is we can only write hello world with it. So we're gonna have to do some actual development to I'll add some more features. Let's start by just define some data types. So it's gonna be an interpreted, dynamically typed programming language. So that's gonna be like one enum to hold like all different kinds of data. Let's see. And then we're gonna have instructions, which are also gonna be an enum. The first is an instruction to create a literal integer, then one to create a list, which it's gonna be a relatively similar structure to the value type, at least for now. But of course, over time, those things will diverge more. So we have now we can specify some minimal programs already. For example, let code Right, so this way we basically just have some really small program that basically just creates a list of two integers, 2 and 3. Always good to do some testing. So let's see, it's probably gonna complain about not finding any implementation of the bug for instructions. And we're just gonna derive those. Yay, it works. But of course we don't actually want to print the code, but actually evaluate it. So we're gonna write an eval function which will return a value. So and it's going to be quite simple. And then actually list as well, now that I think about it. Well, maybe a bit more complicated because we actually have to now recurse. Let's see, it should work. I guess now we also have to derive the bug for our value type. And yeah, I guess we have just borrow, if you just borrow inst, that should be fine. Yeah, so all this bureaucracy you have to do like in Rust, and I guess in other languages which like work at a similar level of abstraction can be quite annoying. But I guess if you want to like write programs which are very which are quite crisp, you actually need to be very precise. Like personally, most of my experience programming is just like dynamically typed programming languages. It's garbage collection and everything, and I like that because it's like easy and there's like a lot of stuff you don't have to worry about, but also there's a certain squishiness to the resulting programs. So although I do get annoyed if I have to have to specify like every detail or like much more details when I work in Rust, I also do like that. Yeah, everything is more crisp, more like more precise, and so yeah. Let's see. But yeah, it's a lot of stuff you have to like take care of. All right, we can now actually run our program. I guess this line doesn't need to be there anymore. So next one is functions. Let's see. Now we get into a part of Rust I'm not too familiar with, because you're gonna need to specify the type of a closure, and that's something that's a somewhat, well, that's yeah, it's not as straightforward as just normal data types. So I guess I'm gonna look at how I solved it in different types in a different program. All right, yes, it has to be like, I think the term Rust uses is trait object, and if I remember quickly, it has to be like boxed or something like that. Like a reference counter could also work, but let's just start out with a box. I mean, at some point when we actually do like some garbage collection, then we will of course use whatever type we use for garbage collection for that. Right, and all our functions will have the type value to result of value because yeah, so in theory you could just call so basically all the functions of the theory just have like one argument, because but of course in practice this one argument is going to be like a list or some sort of collection, so you actually can pass multiple arguments. But I think it simplifies the implementation if you just say, okay, you get a value and then you get, well, not just a value that's either like okay or an error value. Like one idea I have for Yerba is that the notion that like functions can either succeed or fail is like quite essential in the language. So that's why they always just return a result. So let's see what the Rust compiler has to say about this. Right, it doesn't want to generate debug for like function types. So I guess we do have to cheat a bit and do this else. Well, I guess it can be a tuple struct. That's more easy. Yes, I'm going to delete this. Okay, and then we can implement debug trait. Just checking the time. Like my idea is that to have like episodes of like 20 to half an hour. So right now we're like a 20 minutes. So yeah, probably can go a bit longer. And by the way, I'm basically just retyping this from a different project, so it's yeah, LD and this implement somewhere else. And for now, it's going to be real simple. Let's see. Yes. And actually, right now, actually, what I wanted to implement first is a call instruction, which takes two other instructions as parameters. So we actually need to put this whole business into the value. Right, yes, of course we can't have something unboxed in itself, so we do need to box it. Let's do it then. Okay, now it's time to implement call. Let's see. Right, so if it's actually a function, you return a function. Otherwise, you're just gonna panic. So what I'm seeing actually in the type that actually eval has to also return a result. So this is to be okay. Which means this one has to be now an actual closure. Just go with unwrap for now. So what does the compiler say? It says that I can spell. And that I'm confused about the syntax of Rust. Right. All right. So some of these unwraps will maybe get like a nicer error message, but will remain unwraps. But some might actually just have the error value be propagated, like with the result thing. So let's see. Or the compiler's happy, but actually we don't use this new feature. For that we actually need some function, and so I'm gonna have some built-in function first before we implement user user defined functions. So get a value, and this will return the sort of values. Okay. And again, we have to make sure that what we get is an actual, plus we want a list of integers basically. Otherwise, we're gonna panic as well. So now, right, we need to go through those through those values here and make sure they're integers. And then I think there's this some method on iterators, and we need to actually, of course, wrap it correctly. we're gonna panic as well. So you might be wondering, why do I actually bother with the result type if I'm just gonna panic everywhere? And the answer is that actually at some point I'm gonna actually have like a transform error results. For example, actually for the plus function, like if we call it normally, that's just gonna be 3, but if we call it something that, for example, a string, then we're actually gonna get some error. I think so. But yeah, that's the plan. But for now, it's much easier to just panic as we try things out. Let's see your time. I guess we are now more or less at the end of the time I've allotted for this first episode. So in the next episode, I will see if this compiles and then try to actually call this plus function. All right, see you next time.